kg of air at 25 degrees Celsius and 1 bar is compressed isentropically to 7.5 bar. The first one is find the initial and final volume. The second one was find your temperature. Final temperature. The C is enthalpy and what? Internal energy. Internal energy. Yes. While the fourth one is heat transfer. And I gave you some parameters. I gave you CV to be 0.718. I gave you CP to be 1.005. And I gave you gamma to be 1.4. And the molecular mass of air. So now let's solve that question. What are the parameters? So the first thing is you bring out your parameters given. So I'll give you parameters. The first one is what? They give us mass. And what's the mass? 1.5 kg. What's the second thing? Temperature. They give us initial temperature. That's T1 is equal to 25 degrees Celsius. So you are converting Celsius to Kelvin. So 25 plus 273 is equal to what? 298 Kelvin. What's the next thing?
Gamma is.
They give us gamma. They give us gamma to be what? 1.4. They give us CV to be what? 0.718. They give us CP. What's our CP? 1.005. They give us initial pressure. That's P1, and P1 is in bar, 1 bar. Let's convert bar to kilopascal. Multiply by what? 100. So 200 kilopascal. What's the next thing? They give us P2, that's final pressure. Is equal to what? 7.5 bar. Let's convert to kilopascal. So it's 750 kP. What are we giving next?
Mass. Mass.
They give us the molecular weight of air. Now, m of air is equal to 28.1797 gram per mole. So gram per mole is what? Molecular mass. So since we are given the molecular mass, what are you to find? R, and R is what? Specific gas constant. So our R, we know that R is equal to R bar over M of N. And what's our R bar? Our R bar is what? 8.314. 314 divided by what's your molecular weight? 28.97. So what's your R? 0.286, and the unit is what? Joules per kilogram Kelvin. Now look, in your question, they say what? Isentropical process. So the process is what? Isentropical. Now what you quickly do is go back to those stages. The first thing we have to find was what?
Calculate initial and final volume.
Initial and final volume of air. So the first thing was initial volume, and initial volume of air is V1, and V1 is not given. V2 is not given. That was the first question. Now, how can we find volume? What are the formulas there? P1, V1, gamma. P1, V1 is called gamma minus. This was the first one, What's the second one? T2 over T1 equal to
V1 over V2
V1 over V2,
brackets
all in brackets, I mean, all in brackets,
gamma minus 1
gamma minus 1. What's the last one?
P2 over P1
P2 over P1,
gamma
Close
minus
brackets.
all in brackets, gamma minus 1 over gamma, I mean, T2 over what? T2 over T1. Now that was where you were making your mistake. You've seen your mistake, have you? So now, looking at what we have here, the formulas given. We are giving P2, have you? We are giving P1. So can we use this one to get our T2?
yes
Because we are giving T1. What's our T1? 28. 29 points. What's our T1? 298 Kelvin, have you? So now using this one, using what we have here to get for what? T2. So apply this formula. P2 over what? P1 gamma minus 1 over gamma is equal to what? T2 over T1. We know our P2. What's P2? 7 what?
750.
750 over
100.
100. All raised to the power of what? 1.4 minus 1 over what? 1.4. And this is equal to T2 over what's our T1? 298. So what do? Everything here multiplied by what you have here. You have your T2. So your T2 is equal to what you have here, which is 750 divided by 100 raised to the power of 1.4 minus 1 over 1.4, and this multiplied by what? 298. So you do this to get your T2. So our T2, that's final temperature, T2 is equal to what?
529.
529. What?
9486.
9 what?
486.
9486 Kelvin. I mean, let's put this to a whole number like that. So it will be what? T2 is equal to 5 what? 530 Kelvin. That's our temperature, final temperature. So we solved for one part of the question. I mean, what's the second thing?
Find
Now let's get the volume. V1 and V2. Now how do you get the volume?
the formula.
Now let's use the formula for general gas constant. In thermodynamics, I proved that for you. I told you P small v is equal to what? That's what I said. Out. Yes. Where your P is what? Your pressure. Small v is what? Specific volume. R is what? Specific gas constant. And T is what? Temperature. Now, but note, if we are doing this, we can do this to get for your V1 and V2. How do we do that? You know that from what we have here, we can do it for initial state and for final state. But let's simplify this. What is our small v? We know that small v is what? Big V over M. That's what I told you. Yeah. Now we know that this small v, P is, we know that small v is equal to V over M. Volume over mass. I talked about intensive specific properties. So what's our small v? Volume over mass. Now can we take this into this formula? So if we substitute what we have here, it will be what? PV over M is equal to RT. We know our specific gas constant, which we calculated to be what? So what is stopping us from using this to get? We know mass. What is mass?
1.5 kg.
What's our pressure here? Now note, we don't know the pressure. We are talking about initial state and final state. Now to get for your V1, since we have volume here, let's take everything to the initial state. Now taking everything to the initial state, should I do this? You now have what? This is equal to P1 V1 over what? Mass. And this is equal to RC1. This for your initial state. Can we take this mass to this other side? Cross multiplying. Now, if you cross multiply, you have what? V1 V1 is equal to MRT1. Abi? What's our V? We don't know V. We know P1, Abi? We know mass. We've calculated for specific gas constant, temperature. So what is stopping us? Now what is V? Make V subject. V1 is equal to what? Divided through by what? P1. So it will be MRT1 over what? P1. Now what is our mass?
1.5 kg.
So our V1 was mass 1.5 multiplied by 0.286 Abi. What's our T1? 298 divided by what is P1? 100. So you punch this in your calculator to get your V1. So your V1 is equal to 1.278. And what's the unit? Meter cube. So we've calculated for this. I mean, can we calculate for V2? We can calculate for V2 using this formula. Or we use the same approach here. You can use this concept. You can use this. You understand? We know those we know P2. We know P2. We don't know V2. We know mass. We know gas constant. But we know T2. So using the same concept that you use here, it will be what? To calculate for V2, you can use P2 V2 over what? Mass is equal to RC2. Abi? What's our we have to make V2 subject, Abi? So this is equal to P2 V2 is equal to MRT2. Now V2 is equal to MRT2 divided by what? P2. Let's use this formula V2 MRT2 over P2. So V2 is equal to what's mass? 1.5, Abi?
Yes.
What's our R?
0.286.
0.286. What's T2?
530.
530 divided by 750. So now let's get V2 using this app.
0.303.
Eh?
0.3031.
0.3031. Abi? Meter cube. We've used this concept to get V2. Now let's use this concept to get V2. Let's see if we have the same thing. Now using this concept, using this data. So now what is P1? 100. V1 1.278 raised to the power 1.4 is equal to P2 is what? 750 multiplied by what? No, we are looking for V2. Want to use this approach to get this one. Let's see if we get the same answer. Now, okay, this gamma, so this is 1.4. Now let's take this to this other side. So we have V2 1.4 is equal to 100 multiplied by what? 1.278 raised to the power of 1.4, abi? Divided by 750. So now punch this. After getting this, you have an answer. Now punch this, let me see. V2 1.4 is equal to what?
0.1879.
1879. I mean, but we've not removed this 1.4. How do we move it? We can take 1 over 1.4 to remove 1.4 from this.
Okay.
You understand? So this to remove this 1.4 on this other side, it will be V2 raised to the power of 1.4 multiplied by 1 over 1.4. And this is equal to anything you are doing to this side, you are doing it to this other side. So 0.1879 raised to the power of what? 1 over 1.4. So now this can successfully cancel out this. So V2 is equal to everything here raised to the power of 1 over 4. Let's see. So we have 0.3029 meter cube. Let's convert it to what we have here. So it's what? V2 is equal to 0.303. So this is your meter cube. So you can use this concept or this here to get your what? V2. Let's shoot down to anyone of your choice. When we are giving mass, if we are giving mass in the question, if mass is given in your question, then you use your mass to multiply everything on that table I gave you. Whether your workflow, your non-flow work, your shaft work, your change in energy, your heat interaction, your change in enthalpy, or your change in entropy. You use your mass to multiply everything you have there if the mass is given. But if your mass is not given, you leave it like that. You understand? Now, since our mass is given, our change in H will now be what? MCP. Change in what? T. We use this mass because we are giving mass. Now, what is change in H? MCP T2 minus what? T1. What's our mass? 1.5 times what? 1.005. What's T2? 530 minus 298.
349.
So if you add, you punch this, the answer will be
349.
multiply 1.5 by anything.
349.
Did you do that?
349, yes. 349.
349 and
0.74.
0.74. What's the unit? Joules per. This one is joules per what?
Joules per kilogram per Kelvin.
So that's the unit for R.
Joules per kilogram.
What is enthalpy?
Joules per kilogram.
Enthalpy, I told you, don't be confused, get the unit. Enthalpy, Abi? Enthalpy, which is big H, is equal to H over what? H. So if you do this, I told you enthalpy is sum total of what? Heat or energy. And energy is measured in what? Joules. So it will be what? Joules per what? Kilogram. So small h, joules per kilogram. So what is the unit? Joules per what? Joules per kilogram. What's the next thing you have to find? Change in entropy.
No. Is you entropy?
Change in internal energy. Change in internal
Sorry, it's
energy.
you, not this.
Okay. So change in U, abi? Now change in internal energy. Go back to your table. What's the formula? CV change in what? T. We know CV, abi?
So you have to put M. You have to put M.
We have to put M because of the mass, abi? So change in U is equal to MCV change in what? T. We know our mass to be 1.5. CV is what? 0.78. 0.718, abi? What's change in T? T2 is what? 530 minus 298. Now what is your change in U?
249.8.
249.86. And what's the unit? Joules per what? Joules per kilogram.
Minus 1.
Is there any what? But wait, why didn't we use kilojoules per kg? We are using joules per kilogram.
Because why the formula you gave us for anything regarding energy?
Now wait, did they give us anything in kilo?
No, we converted to kilo.
We converted to kilo.
Kilopascal.
To kilopascal. And we are using what? Kilopascal. So what will be your units? Kilojoules per kilogram. So make that correct. So this one is what? K joules per kilogram. This is what? K joules per kilogram. Because of the pascal, the bar we converted to what? Kilopascal. And even we converted it to pascal, we use joule. But we converted it to what? Kilopascal. So we are using what? Kilojoules per. Now what's the next thing? Change in entropy. I mean?
No.
Heat interaction.
Heat interaction. Now I gave you the formula for heat interaction in that thing. I told you heat interaction is what?
0.
Zero. And what's the symbol? Q.
Q1.
Q1 2. Why is the 1 2 there? State 1 to state 2. So we know that our Q1 2 is equal to what? 0. So